Hello YouTube Vintage Stereo Collectors. This is video number 11 for the KA-2000 restoration. All the caps, resistors, transistors, all the rework is done. Right now I've just been running the amp. I turned it on, put a meter on an emitter resistor of each of the outputs. Initially when I turned it on I wasn't getting any bias. And we're reading in millivolts here. That's because it's a little, since replacing the germanium PNP transistor, changes the circuit slightly. So I use the bias adjustment to bring it into range. Here's one thing I figured out with these. Originally, you're looking at 14 millivolts across each resistor. What I found is when you go with the silicon transistor, which matches, so the PNP and NPN are both silicon transistors, they're both turned on at a higher voltage, okay? You need less bias. I know it sounds weird, but there's actually a higher bias voltage on the base of the transistor, but less bias current flowing through the emitter resistors. It's just nature of the transistors. And so what I found with this situation is you really don't need them turned on as hot. I used to set them 12 to 14 millivolts on each. Now I set it 4 to 5, and it just seems to sound good that way. But another way of looking at this, you can put a tone through it and look at it on an oscilloscope. So I have my little mini oscilloscope, because I actually have bigger, older test equipment. The funniest thing is I like the vintage test gear, but I don't use it much anymore because it takes so much room on the workbench. That's the thing. So I'm going to turn this on, set it there, and we're just going to go do a couple of basic tests. So first one I want to do, I want to clamp onto the power supply, okay? Right there. And then just do an auto calibrate. So it's reading 42.4 volts, RMS. Look at the line, 0 ripple. So it's very well filtered. Hopefully you can see all this. I know it's small, but that's an important thing right there. Now, next thing we want to do is we'll put 1,000 hertz tone through both channels. So I have my tablet set up. Here's my tone generator, and I actually have 3 other tone generators, and they're vacuum tube and they're big, and they're kind of cool too. But this one allows me to have everything kind of in close quarters, and it makes it easy to work on. What I'm going to do, I'm just going to get the tone on, make sure it's there. It's on the aux channel. Yep. It's there. Okay, so we have 1,000 hertz tone. And I'm just going to clip on right to the output, ground, and the output is right there. And I'm going to try not to zzz anything. And we'll put this in auto ranging mode. So there is your waveform. A sinusoidal waveform. It's 80 millivolts output, right on 1,000 hertz. And one thing you're going to notice here is I'm going to just inch it up a bit. Recalibrate. there is at 5 milliamps of bias current, and the idea of putting that bias current into this circuit is to slightly turn on the transistors so you get the positive swinging sinusoidal waveform and the negative swinging sinusoidal waveform matching. There is no, like, zero mismatch. Both peaks and valleys are the same. That's what you want. If there's no bias there, it would be shifted. Let's go the other channel. Right there. So, the other channel is at 68 millivolts. So that tells me one thing. One channel is slightly less than the other. This has a split shaft volume control. So I don't know if they're even lined up. I'm just going to, if I can feel it. So that channel's set at 97. Let's just double check this here. Yeah, there is a little bit of a mismatch. I can't really reach it enough to adjust it. I just have it listening in the headphones. Yeah, the right channel is just a little bit louder. When you have analog rotary volume controls, tone controls and stuff, and they're stereo, you have one shaft turning two variable resistors. They can get a little bit out of sync. Let's just put it up a bit. Maybe we can figure out where the mismatch is. So I got it at half volume. Everything's cool in this baby. Nice and cool. So 130 millivolts. Look at that. No crossover distortion. So 286 millivolts. Go to the other channel. 266. So the discrepancy is less at mid-volume control. So it's what I thought was. It's just a slight mistracking in the volume control. And you can adjust it because it's a split shaft. I just can't do it where I'm sitting now without disconnecting and turning it around. But there's no distortion there. That's really running clean. That's pretty impressive. That's one thing about these. They don't break up. You don't get distortion until you're really pushing them. And I'm talking about, 12 to 14 watt amp here. That's one of the niceties. That's why they sound so good. There's other things you can actually look at too. DC blocking, for instance. So, if you go on the center voltage pin, have it auto range, 21.2 volts there, okay? You go on the other side of the capacitor, 0 DC volts, 0. That cap is blocking like it should. 21.2 on this one, 0. That's like textbook. That's all I can say. Anyway, I'm going to put it together and listen to this one for a while and do a report on it later. Thanks for watching and listening.